Okay, here's another question from exam number 2. And you're supposed to draw the complete Lewis structure for the iodine pentafluoride molecule. At this point, I had given you the formula for iodine pentafluoride because you were not yet required to do that part. You were required to write the structure, though. So we look at this, and you remember that the least electronegative, these are both halogens. So normally halogens that you're familiar with now are usually terminal atoms, but here you have two halogens. The central atom is going to be the least electronegative, which is iodine, because fluorine is, well, actually fluorine is the most electronegative element on the entire periodic table. So that's iodine is going to be your central atom. Now it's a halogen, so there are 7 valence electrons. So there are 1, 2, 3, 4, 5, 6, 7. Now fluorine has 7 valence electrons. You have 5 of them. So each one's going to need 1 more to complete its octet. So your objective here is to give all these terminal atoms a complete octet. So you will have a fluorine that you can put here. 1, 2, 3, 4, 5, 6. Like that. It has its 7, and it's going to share with that one. And then ultimately you're going to do that all the way for all 5 fluorines. So you end up with iodine. You'll have 2 electrons that are not bonding, and then you'll have 5 Fs. You don't have to draw any stereochemistry if you don't want to. That's no problem. But your 5 Fs go around, and then you've got to give all of your non-bonding electrons around each fluorine. So just like that, all of them. Just got to draw them in so that you show the octet on your terminal, on each terminal fluorine atom like that. Okay, so now all the outside atoms have their octet, and then you have bonded pairs between the iodine and fluorine here. So this would be your, it says in the box provided. I just didn't draw a box on this copy when I copied the problem over. Alright, based on the Lewis structure, describe the molecular shape. So this requires, unless you have a fantastic memory, you to look at your reference materials. This was a VSEPR, the valence shell electron pair repulsion theory sheet that I told you could use as a reference material. And now you're going to look around your atom, the domains, and see how many are there. So you probably already know there are 6, but we just count the domains. There's 1, 2, 3, 4, 5, and the lone pairs count. So that's 6. So there are 6 domains. 5 of them are bonded, and there's 1 lone pair on the iodine. So you're looking around the central atom, right, to describe this. So the central atom has 6 domains around it. 5 of them are bonded, 1 of them is not. So you go to your sheet, 6 domains. You're looking at 5 bonded and 1 lone pair. The molecular shape is square pyramid. So you just write that in. The electron geometry is also found on here, octahedral. And the hybridization is also found on here as sp3d2. So you don't have to know every single thing about the valence shell electron pair repulsion theory, but you do have to know how to draw a Lewis structure correctly, how to identify how many domains it has, and stuff like that. If you draw it correctly, you should be able to determine its what's bonded and what's not, and if you have your reference material, you should be able to look at that and determine answers to questions like these. And hopefully, if you get a question like this on your final exam, between this and your reference tables, you should be able to arrive at correct answers and get some points that way.